Okay,
Hello?
you hear me? Can you?
Yes.
Yes. So what we are going to do now is we follow the definition of a function. But this time, instead of looking at them as two sets of numbers, calling them range, calling them domain and range, we look at them, we look at whether they are function or not in the form of graph, calling the x-axis domain and the y-axis range. So I choose one number from the domain, like that. I choose one number, 7. Okay. I choose one number 7. Then cut across the graph and look at the range. And the range there, because they cut at 2 points, then there are 2 numbers in the range. So it is 1 to many, 1 to many. So this is not a function. But to be sure, I look at another number, 7, 8, 9. I look at this number 9. Then I draw a straight line parallel to the y-axis, or maybe they call it a vertical line, right? I draw a vertical line. And again, this vertical line cuts the graph at 2 points, giving rise to 2 numbers in the range. The 2 numbers in the range, 1 to many, right? I choose the number 11. 11, I see, also cut at 2.1 here and 1 here. Lastly, I choose the number 14. Also cut at 2 points. This number 14 also cut at 2 points. Then I choose this number 16. 16 also cuts at 2 points, giving rise to 2 answers. So now I'm very sure this graph like this in a circle, it is not a function. Probably it's a relation. It's a relationship between 2 sets of numbers, x and y, but it's a relationship, but not a function. So we look at the next graph like this and try to see whether it is a function or not a function. So this time, I'm going along the x-axis and choose a particular number. Let's say this number is 3. 3. This number 3, it cuts the graph at 1 point, right? And that gives rise to a number in the range called 4.4, something like that, right? So one number at the domain correspond with one number in the range. So this is very likely that it is a function. Show one more. One number 7 cut at 1 point, give rise to one number in the range, 5.3, something like that, right? One more point. This is what? 7 is, well, 5, 6, 7, 8. This number 8 cut at 1 point, give rise to a number in the range, only one number, right? This one, number 12. 12, I shoot up vertically, or maybe draw a line parallel to the y-axis. Then it cut at 1 point, then I see, oh, there's only one corresponding number in the range. So now I ask you, is this line, does this line represent a function? Yes or no? This line.
Yes.
This line represents a function, correct? Okay, so your lecture notes say we try to look at this one. So we try to look at this one, right? Okay. So we look at an equation or a graph like this. Does the equation of this graph represents a function? So I take one number, 2. Okay. This number 2 here, I draw a straight line. Don't just stop at the x-axis. Go down some more. You can go down, then go down some more. I see that they cut the graph at 2 points, one at the bottom and one at the top. So you don't expect the 2 points always to be above the x-axis. Sometimes they may cut above the x-axis 1 point. Below the x-axis also they cut at another point. So there are 2 points. They cut at 2 points. So now I choose another number. This number is 1, 2, 3, 4, 5. So this number 5, I draw a vertical line which is parallel to the y-axis. Draw a vertical line until below the x-axis also, never mind. I see they cut at 2 points, one at the top, one at the bottom. I choose another point, 10, x equal to 10. That means the domain is 10. I didn't write down domain. Where's domain? Range, domain. Okay, so I found one number 10 at the domain. Domain is these numbers along the x-axis. So I find one number in the domain, and this number correspond with 2 numbers in the range, 2 numbers in the y-axis, right? One more. This one. So this number is 13. 13 also has 2 numbers on the range, in the range on the y-axis. So now I ask you, hey, this curve, does it represent a function? Yes or no?
No.
No. Okay. So very good. So you know how to look at the graph and tell whether it is a function or not. You also can look at this diagram, right? This diagram, and see whether it is a function or not. If this type, function, if this type, function. This type and this type, not function. So now you look at the you look at the graph, you can see whether, not at the diagram, but at the graph, and you know whether it's a function or not. Okay, now the lecture notes move on to domain and range. This one I already taught you earlier, right? So what is a domain? What is a range? I already taught you earlier. So never mind. Read again, right? Read. Okay, can you hear me?
Can.
Can. Okay. So now, your lecture notes introduce what is a domain and what is a range. Here they say that the domain is a set of input values for a function. So I tell you, oh, this domain is the value of x here, right? The domain is the value of. Then they tell you, oh, range is the corresponding output values. So I tell you, oh, the range, they are numbers on the y-axis. Okay, right. Now they want to ask you, hey, can you tell me, I give you a graph. Can you tell me what is the domain and the range? That is what they are trying to ask you. You look at this figure 1 here. They show you part of a graph from this point until this point. Then they say, hey, what is the domain and the range for this graph here? Okay. So now I transfer over here to explain to you how to look for the range and the domain and the range. Okay, now if you look at my graph here, it's a very long graph. But now I want the graph only from A until B. From A until B, that means from here, dot, 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 until here. Now, this part of the graph, this one not counted, you know. This one not counted. I just want from here, from B here until A here. So that part like this. Like this. Now, this part of the graph, can you tell me what is the range and what is the domain? Okay or not? You understand what I am asking? Okay. It means that this blue line starting from B go until A here. Only this part from B until A. So if you concentrate on this part, can you tell me what is the domain and what is the range? Okay. Now this part from B to A, the domain is from here, no? The B, the domain is from here. The A is until here. So the domain is from here until here. So this is the domain. And it is from 3 until 13. The way your lecture notes denote the domain is by using two numbers. The smaller number along the x-axis and the bigger number, the biggest number along the x-axis. And if it is inclusive of the two numbers, then you use a square bracket. If it is not inclusive of the number, then they use the round bracket. Okay, so now the domain is from 3 to 13. 3 until 13. Okay, that means all this from 3 until 13. Sometimes, if I want to write it in terms of x, it will be x such that it's a set. The domain is actually a set. X such that it is between, x is between 3 and 13. So it's like that. This type of bracket denotes the set. This type of bracket denotes the set. So you either write it as 3, 13 using the square bracket, or you can say x such that x is between 3 and 13 inclusive. So the equal sign is there. 3 less than or equal to x less than or equal to 13. So this is the domain. So I try to use a torchlight and shine at the curve from the domain. I switch on the torchlight. My torchlight is blue color. So that means you can see clearly this part of the curve. This part of the curve. The domain is from here to here. From here to here. From here until here. From here until here. Right? From 3 until 13. This graph. It is not the blue color. The blue color is to show you I project up from the domain. The blue color is actually referring to the x value of the curve is referring to the x value of this curve from 3 until 13. Okay? It's not the area here. The area here is not the domain. The domain is the value of x from this point until this point. And the value of x is here, 3 to 13. Any question regarding this domain?
No.
No. No. You know, right? So this is my domain. Where is the range? From here until here. So I see. Show me the range. The range for this curve, the range is not from here until here. The range is not from 11. It's not from 10.98 until 6 point something. No, because the curve actually go down until here. So my range is actually until here. I show you. Okay. Now this part of the curve from A until B here. So can you say that this thing here is the range? No. If the range is here, it will only cover this part and also this part. This part also included, This part also included. So actually, the range is until here. It's until the bottom here. So it is from 4.67 here, 4.67 until 10.98. Until 10.98 here. So this is the range. Don't say that, since the x, they stop, the x stop at the B here, or stop at the B here. So I take the range from here until here. Because B A to B A is here, A is here, the range is here. B is here, the range is here. Also is from 6 point something until 10 point something. No. If you take 6 point something until 10 point something, then this part of the curve is not included. So you cannot take the two extreme points. You can take the two extreme points from the top until the bottom. It's not from the left to right, it's from the top until the bottom. So although it starts from here, then end from here, but the lowest point is here. So the range is from here until here. Any question?
No.
So you can understand why the range is from 4.67, which is the lowest part of the range, until the top here, 10.98, the highest part of the range. The highest part of the range until the lowest part of the range. That is the range, the whole range. So if you want to write in bracket form, it will be the square bracket 4.67 comma, then the 10.98, the highest point, then the square bracket. Square bracket means these 2 points, they are included. These 2 points, they're included. Now, if you want to write in the form of, the set notation, then you should write like this. Y such that Y is between 4.67 and 10.98. Right? So this is the range. In order to find the range, you must find the highest point and the lowest point. That is the range. If you want to find the domain, you find the extreme left, and the extreme right. So between these two extremes, they are the domain. Between the top and bottom extreme, they are called the range. But you have to focus on the part of the graph, right? For that part of the graph, what is the range and what is the domain? Okay, right. Now, your lecture notes, they say, hey, this equation, can you draw out this line on the y-axis and tell me, oh, what is the domain of this function? What is the domain of this function, and this function? Okay, so the general type, the different type of functions, they also show you the shape of the different type of curve. This one, Okay, so now, this one, okay. This is the first one. Y equals to 5 minus 7x. And they ask you, what is the domain for this? So y equals to 5 minus 7x. Oh, the equation is like this. So the line is like this. Okay, this is the line. So this line is very long. It can go until the very top and go until very bottom. There is no break in between. So if I want to look for the domain on this line, so I look at here from along the x-axis. I can have 0, 1, 2, 3, 1, 2, 3, 4, 5 until 10 and so on. So this line will extend until infinity. Then I look along the negative part, negative 0.5, negative 1, negative 2, and so on, until infinity. So this is my domain. My domain is from negative infinity to positive infinity. So I will type like this. Oh, my domain, D-O-M-A-I-N. My domain is this one. Bracket negative Where's the infinity? This one. Negative infinity and until the positive infinity. Positive infinity. Then I close the bracket. So this is my domain. Now, if I want to ask you the range, where should you look? Where should you look at? Where should you look at? You should look along the y-axis. So you see here, all also got this part, all the y-axis, it just looks horizontally. Horizontally, the y values, negative until negative, positive until negative. So the range is also from positive infinity to negative infinity, right? Negative infinity, then comma, until positive infinity. Right? So this is the range and the domain. Any question on this? How to look for
No.
the range and the domain? You look along the x-axis, right? If all the values got, then from infinity to negative. Unless the graph start from middle somewhere, then you start from that point, the domain. And until somewhere here also it stops, then you look at until there. That will be your range. You see where they start from the left, where they stop on the right. But this one never stop. This one extend until very far. So we say infinity. The same with the range. You see where is the highest point along the y-axis, where is the lowest point along the y-axis. So there is also no maximum point or minimum point. So it's from infinity to negative infinity. Any question?
No.
No. No, then we look at part B. Part B, this one, graph, plot new function, square root x minus 2. X minus 2. Okay, you see here, square root x minus 2. Okay. Aha. This one is not the same. If you see carefully, then you tell me, uh, then you tell me where they start. The maximum on the left and right, the maximum at the top and the bottom there. Can you tell me what is the range from where to where? This is the function, square root of x minus 2. Now, first of all, you look along the x-axis. The value is from where until where?
Range. Two.
From 2. We start from 2. Exactly 2 or equal to 2 or no equal to 2? Equal to 2 can or not?
Equal to 2.
And then we put this one. Let's say you put the x equal to 2. 2 minus 2 is what? 0. Square root of 0 is 0. Yes, you can start from x equal to 2. Then, is there any stop at the right-hand side? Or
No.
they go, no stop. Okay. No stop, then we say infinity. Then we say infinity. Okay. And infinity is not inclusive one. No? We don't know what is the value of infinity. So you put a round bracket there. This is the domain. Range. And you tell me what is the range? The highest and lowest value?
Highest infinity
Highest is infinity. Lowest?
2.
Hmm?
0.
Correct. Equal to 0, can or not? Can. So you put
Can.
the square bracket there. Then infinity. Like that. Okay, very easy. Okay, this one, 1 over x minus 2. Okay. This one. Graph. So this is 1 divided by x minus 2. Have you seen this type of graph before?
Yes.
Yes. Where did you see? What is it called? This is called the inverse function. Right? This is called the inverse function. This is actually the general type is 1 over x. Because it's minus 2, the line shifted to the left, to the right, sorry, to the right too. This is the line that they shift. X equal to 2. This is the okay. Now you see that this graph, this graph, the blue line, is this function y equal to 1 over x minus 2. Now this graph actually consists of two parts. One part is at the top here, and another part at the bottom here. In between these two graphs, there are two lines. There are two lines. In between this graph, these two parts of the graph, one line is this one, this dotted line, red in color, and this line is actually x equal to 2. This line is actually x equal to 2. X equal to 2. This line. Then another one is actually this line here. Another one is actually this one. Another one is actually this black line here, the x-axis. The x-axis. So this blue line